I'm here to talk about data analysis and visualization according to the FAIR principles. We won't talk so much about the principles. I hope this was also covered during the last days, but we were mostly talking about data analysis and visualization with the showcase data we have here in the workshop. And I'm an R user, so I'm going to show you an R workflow, but I hope if you're not an R user, that this is still kind of like gives you some insights and hopefully also some guidelines and ideas how you would do it in your preferred setup. Okay. First of all, who am I? I'm an independent specialist for infographics and data visualization. I'm a trained ecologist. I got a PhD in 2019. I was working mostly on movement ecology of animals and disease dynamics, partly also community dynamics and nature conservation. But I realized that I love crafting charts and maps, maybe a bit too much than compared to my writing part. And yeah, I got into this more as a hobby after my thesis, so during my thesis and after my thesis. And then at some point, there was some interest, and I was like, well, let's try and see if that works as a freelance position as well. So I design these things mostly with code, partly also with classical design tools. Also teach a lot, and obviously there's also the usual dashboard and report design. So I'm kind of split my daily life in three parts, like coaching, like this one here, consulting, where I help clients to improve their workflows, but also to improve the graphics and the communication of their data findings. And then I'm mostly doing this with coding, and that's what we are here for, and mostly with the R programming language. So this is some of my early visualizations we want to like that should look familiar. It's typical academic graphics you create for papers, presentations, and so on. Nowadays, these graphics look a bit more different, maybe a bit more colorful, a bit more playful. Doesn't mean that all of these styles apply for a certain use case, right? We still have like very clean business report graphics, but sometimes we also get a bit more playful. If I'm on my spare time, it gets maybe a bit more artistic and even more creative. Most of these visualizations are, by the way, the product of code alone and no manual changes afterwards. If you want to learn more about me or see something about that, I have a blog. I just want to highlight in that realm of the course. I have two related to ggplot, if you're into that. One ggplot tutorial, which became rather long, to create all kinds of things. It's a bit unstructured, more like a how-to. And then there are materials for several workshops. I want to recommend a 2-day workshop on graphic design with ggplot I gave 2 years ago in Washington, DC. And all of the materials available. So the slides, the exercises, the scripts, the solutions, and so on. Okay, this leads me to the materials of this course day or this session here. So as usual, it's uploaded to Zenodo. You find the DOI here. I also uploaded a compressed folder on my own web page. There you will find the PDF slides, the script in R, and the Jupyter notebook to follow along or to try out later. Okay, let's jump into the topic of data visualization and data analysis. Okay, so in very broad sense, data visualization is any graphical representation of information and data. So that for me, it means that data visualization is all around us most of the time. I love to kind of think about like being a kid at the beach and collecting shells and sorting them by color or size or whatever. I'm not sure if you've done that or any other thing, collectible thing. We could also frame it in a context on how or why we are doing data visualization. For example, we want to help to amplify cognition. We want to gain insights or let people gain insights. We want them to discover, or we want to explain something, and maybe also to make a decision. You could also frame it in a more technical context, like data visualization converts information into visual forms as quantifiable features. That's only partly true, I would say, because there are also some visualizations which are not so focused on the quantification, but I think in an academic and research context, that's definitely something we want to achieve. And finally, we could also phrase it a bit more philosophical, like data visualization is part art and part science, because we have obviously the design and the layout and the arrangements, but also the statistics and the handling of proper encodings and so on. So why is this important and why do both go hand in hand? You may know this example, I don't know. It's the Datasaurus dozen. It's a set of 13 data sets, which all look very different. But if you kind of go into this data a bit more detail, you will see that the summary statistics along the X and Y axis and the correlation are all the same and exactly the same, which is maybe surprising. And if I would give you a table of all these numbers, you likely would have a hard time seeing what's the difference and what's the similarity about these data sets. And that's basically a use case or like a showcase to say like, well, visualize the data, get your statistics, but it's not only the visualization, because often it's then the other way around, well, and then you're just looking at your points and making up statistical correlation or whatever. We do both, right? So Anscombe, who is the founder of this idea of having data sets of different shapes that with the same summary statistics, said that we should make both calculation and graphs because both will contribute to understanding. So that's the original graphic from Anscombe, the so-called Anscombe's quartet, which is exactly the same in a less fun way than the Datasaurus dozen, where we have 4 data sets and obviously only one follows the typical linear relationship. The second one is a nonlinear relationship, and then the other 2 have outliers, or what we would likely consider outliers to one of the directions here, where we would maybe need to handle that accordingly or remove it beforehand, depending on the type of outlier. Another real-life example why visualizing data can be helpful, and sometimes it's hard to just see from your data sheet. This is a visualization by The Economist based on an actual research contribution by Dmitry Kobak and Sergei Spilkin. And they analyzed, it's a bit dated by now, 2021, but they analyzed Russian results from the elections to see kind of like this grid of points appearing here, which gives us a hint that there are an unusually high number of turnout and vote shares that are multiples of 5. So we see that the grid is originating here and gives us the idea that there are too many exact results, which are very, very unlikely. And that's something which is also part of the journal business nowadays. I love to see positions which are called data detectives. I actually would love to be a data detective just for the title alone. But these are people who work for journals and look at the data, obviously also at the raw data, at the tables, but partly also in an automated way and partly then also in a visual style. They're looking for strange anomalies in the data which give a hint for manipulation. Not sure if you have heard about the Spidergate. I don't have time to jump into that, but that I think was one of the main initiations of creating these positions. So what makes a good data visualization? A very broad and open question. I'm not here to kind of completely answer that and give you the template for that, but I like to think about data visualization or the design of them in 4 steps. The first step is the information, the integrity of the data. That's actually before visualizing or while exploratively visualizing the data, making sure that the data is accurate, that the data is researched well, collected well, and we try really to answer or maybe even to like a good hypothesis testing, right? To maybe find the other perspective on that. The second then is to working with the data to find a story, and this is something which may sound a bit counterintuitive, especially for scientists, like, well, data and stories. And it's not about making up a story. It's not about like finding data to support a story or something like this. It's about, why do I want to show this data? So I think the worst case for data visualization is often that people are like, well, I've collected this data, I plot it, and then someone else needs to find out why this is interesting. And the idea here is that we kind of think about what's the most important information we want to show, and then we focus and work towards that goal, right? So basically having your title, a short title of your visualization in mind, and then trying to yeah, improve the graphic to support this so that people who look at the graphic is the first thing. Basically, they can interpret from that and comprehend from the graphic is what you want to tell them, and they don't get lost in other details. It's still fine to provide more information, obviously. The third step then is the usefulness of your graphic. So the goal, this is more than about picking suitable encodings, like should I use the height or the length of a bar or the position of a point or the color gradients or whatever. So the encoding. And then overall that leads to the chart type. So it's the chart type a valid one to represent the data and tell the story. And the last one then is the visual form, the beauty. Some people don't like to call that a beauty because it sounds a bit like, well, beautifying the visualization in a way that maybe even distracts from the actual data. That's not the point here. It's about really guiding the people and making them stop, right? We are in a very, very overcrowded, fast-paced world where we maybe also want to kind of get the chance to even tell the story to someone. And I at least believe that if you see that people have taken care of that and they are kind of worried about it and they're kind of like into it, that yeah, just motivates people more to stop by and take a look. And all of these in combination and hopefully then make a good data visualization. And obviously, there's also the other way around, nothing here for this session, but there's obviously also a way of making bad data visualization to get a spark, right? That people like, what's this? And people get into discussion, but that's not what we are here for. And I'm also not sure if it's a good strategy. But obviously some strategy where you get a lot of reach. Okay. So back to the data analysis and visualization in our daily life. I'm brought here the data science workflow, where most of the steps we will also look at today, not in detail, but just to kind of like put us in the circle here. We will obviously going to import our data. We don't really have to tidy or clean it, but then we are going to analyze, modeling here, in our case, just descriptive summaries, and then visualize the data. And then this is an interplay. Again, I want to kind of highlight that it's not you do one or the other, it's both go hand in hand. And then once you have kind of like successfully moved in circles here, you're at some point going to create a data visualization that should communicate your results in the paper or multiple data visualizations, right? So this is the explorative part, and then we go to the communicative part, the explanatory part. Just shortly to mention it, I'm not really an expert here on the FAIR principles itself, and I'm not also going to kind of really go into detail, but I thought, like, as it's in the title, I will put it an overview in here. So for me, it's really mostly that we're going to do a code first. So FAIR principles are a bit wider here. I think this is what you kind of gain from all the course here during this week. So the findabilities, I'm not going to spend how to share our data visualizations in the sense of the codes, because I guess that has been covered already. But the accessibility, the interoperability, and the reuse of the digital assets. And I think all of this leads us in the end to what we also discussed when I entered the room about like digital ways to kind of like do our analysis and reproducibility, transparency, and so on, all these concepts, which I also think are very, very important, not only from a legal way, but also from an ethical way. And I'm going to mention it multiple times, the tidyverse packages, the R environment. So there are other packages you can use, obviously. I'm going to show you ggplot2 here, and this is part of this ecosystem. So I also like to use the other packages. So these packages belong together as a collection of packages for data science tasks. And they have kind of like they work very well together because they have the same philosophy and the same syntax and data structures. Just a short overview, not going into it. There are more packages to this. So if you a more seasoned R user, tidyverse user, you may know some of them. If you're not an R user, this is completely unimportant to you. But if you're somewhere in the middle, You might want to learn more about just the basic or the main packages. So I brought this one here where you see that there are highly specific packages for some tasks, different data formats, and then also other for modeling, especially and communication. There are tons of packages you can explore. And also then even outside the tidyverse, obviously even more. Okay. If there's no question to the general part, I jump to the workflow example. I decided to, if that's fine for everyone, to use slides because in the Jupyter Notebook, kind of like it got a bit messy with all the visualizations and the long tables for me. So I would prefer to present the slides, but as mentioned, the Jupyter Notebook is attached to the course materials and also an R script. So if you want to jump in there, I can also give you a quick look, but I believe you all have seen Jupyter Notebooks by now and created your own, so that should be fine to just open mine. I'm not sure if you have access directly to it. If so, I wasn't sure. So I uploaded the other one yesterday evening as well. And there we will find also a bit of comments of myself and then a lot of code and the plots we are going to look now in a clean way and the analysis steps. Okay, so the first step is getting the data in. And as I haven't been part of the other sessions in detail, I'm not sure if you have or which packages you have used for that. I'm shortly going through my usual workflow or my thoughts on that. So the read.csv base function we could use for that to load local data. So now here the data is in the data folder where I access it and store these data sets in two objects called TryDB and GBIF. As we are going to adhere to the R packages, the tidyverse collection, we are going to use the read_r function. Actually, for import, there's not so much of a difference, but the most important thing for me, at least, is that it returns a tibble. A tibble is a modern data frame, at least that's how they call it. And this has a bit nicer printing, especially, which I like better because in R, if you kind of have these regular data frames, you end up with these very long outputs, which are wrapped into multiple lines, and that we can avoid here. So I like to use the read_r package and a bit of R philosophy here. I'm using here the namespace version. So if this has been mentioned before, I'm not going to jump into it in detail, but just a short reminder if it has been mentioned. This is the package name, and then we have something which we call the colon, which is kind of like connecting the package with the function. So basically, it's like a dictionary, like a lookup. We use the read_csv function from the read_r package, and we use the here function from the here package. There's three reasons to do that. The first reason is I don't want to load the package and only want to use a few functions, or I'm lazy or whatever. Then you can type that without loading the package. It needs to be installed though. The second is that we want to avoid, or if we want to avoid name conflicts. So sometimes there's the same function name in multiple packages, so we can avoid that it's using the wrong filter function from a different package. If you run into errors, by the way, this is the best thing to do as one of the first steps because it happens from time to time. And the third is like from an educational perspective is that you can see where these functions are coming from. So usually if there's a namespace in front, if I don't say something else, these are the non-basic functions. So long story short, you could also just load these two packages and then run it without these namespace conventions. The here package is something which is very specific to the tidyverse, I think. But I like it a lot because it makes the navigation in your workspace a bit easier. This is especially if you're rendering reports like Quarto or Markdown. So if you have subdirectories and so on, you usually kind of like, so the document has its own root directory, then your project and so on. So it's basically making a common sense what's the root directory and navigating from there. So here we have the slash annotation where we say like in the data folder, use this file. And the here package basically checks where there's a project file. And from there, it goes into the data. And then they just find this a bit cleaner to write it with a comma instead of the slash. And finally, if available, you could also source them from a URL, the data set. So that might be the best here now. If you don't have a copy yet, you can directly source it from GitHub. Okay. So once the data set is in, right, the first thing what we do is the data inspection. So I'm going to use the glimpse function from the dplyr package, but there are obviously also base functions to do that. The glimpse function, now I need to think about what's the base function because I haven't used it in years. It's summary? No, it's not summary, it's the other one. Strew, right? Exactly, strew. Thanks, Mami. So you see, I'm completely lost in the tidyverse. But yeah, you see also that it's giving you similar results. I think what's the additional value is that we directly see the dimensions of the data, and we see, no, I think the data, the type you see as well. We also see that we get an ID column. We don't mind for now. The species name, the trait name, the value for the outcome, and then the unit which belongs to that value. I don't like to work with these uppercase connotations, so I'm using a tiny package janitor to clean the names of the columns, so turns everything into lowercase, snake case column names. You don't have to do that. That's just a common thing for me to do. And if we now glimpse at this data, you see now it's not dot 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 one, it's x1, and then we have species underscore name and so on. So just take care if you want to use my code, but you like your uppercase variables, you have to update the column names accordingly. So quick look into the data, what's actually in there, just not an extensive inspection here, but giving you some functions that can be useful to do so, to do some descriptive statistic, right? Is this true function we have here about in the glimpse function, but if I want to, for example, see the unique values of a specific column, I can pass that dataset $column name, and then in a unique function, and it returns all these values. Be careful if it's numeric, obviously. If it's continuous, so floating numeric, then you end up with a very long unique list, obviously. So don't crash your computer, which is not so easily possible anymore. But back then it was by running such functions. If we wrap that into the length argument, now we look at the species names here. But if we wrap that in the length, then we see the unique number of unique whatever entries. So here we see we have 41 species in the TriDB dataset. We could also, if we have a numeric number, we could use functions like the sum, the mean, the median of something. So let's look at the median of the values in here, and oops, we get an NA. NA means not available, and the common conventions, or I think it's also beyond R, but in R, it's like if there's any unknown value in our data, we don't know the outcome of the statistic, obviously, because I can't tell if it's 500 or 0.5, so I can't calculate a median or mean or a sum of something where there's missing information. Nevertheless, it would be helpful to get this information. So in R, you have to specify then the condition that you want to have the NAs removed. So NA.rm is the not available data removal argument, and we set that to true, which means we activate that. And then we see it doesn't make sense here because we have lots of different traits here in units, right? But then we get a number here. We could also use the quantile function if you want to see a bit more of the structure of the data, where we can even specify the breakpoints, but here we get the regular quartiles of the data, and we already can see that it's very, very skewed, right? Which makes sense, and we will see in a later step as well. Then the summary functions, that's also sometimes helpful. So for the factors and character classes, it's usually just the sample size, but especially for numeric values, it gives you the same overview. So the quantile functions, for example, and a few more. Another one I like to use to kind of get an idea of data is the count function from dplyr. where you can simply count observations. In the most default or most simple use case, it doesn't really make that much sense because the only number I retrieve is the overall number of rows in my data set. But this especially becomes interesting if I kind of pair it with a column name. So I can basically create all kinds of combinations and retrieve the number of observations here. This is species now. You could also look at the traits, which of the traits are mostly represented in the data set. But you could also combine multiple ones. So now it's the combination of species and trait and then the sample size. And obviously, we will see a bit later, we could also sort that to make it a bit more easy to understand. So currently it's sorted as the data. So I think it's alphabetical with regard to both species name and trait name. Okay. As a next step, we're going to look into creating our own small data sets to work with, or maybe kind of like subsets of our data. So the next step is the data wrangling. And in the tidyverse, the usual package to do that is the dplyr package, along with some others we are going to see, but let's focus on that one. Again, not extensively going into detail here, just showing you the main functions or verbs, how they call them. It's the filter to pick rows, the select to pick columns, and then we have arrange to arrange by one column. We have mutate, where we can create new columns or overwrite existing ones, and then we have summarize to condense our data. And then in the end, we will have a short look at group by. So we have to, in this case, I load the package. So when you will not see a namespace anymore because I'm making heavy use of the package. And the general idea is that we have the verb, so the function name, like filter, select, mutate. And the first argument is data, comma, and then the condition. And that applies to most dplyr functions, but also many of the other functions in the tidyverse. So for example, we could say like, well, we are just interested in the leaf nitrogen content per leaf area. That's what we want to look at in the next step. So let's filter our data. And so the filter command data, and then the condition is that the trait name should be equal to the trait we have chosen. We could then store that in a new data set or overwrite the old data set, whatever, not recommended. So better to create a new one. So we call it trydb_nitro. And now we could run a select, for example, where we just keep the species in the value because the trait is anyway the same in the unit as well. So that would be one workflow, but here we would need to save intermediate results. Some people like that, and it's totally fine to do that. And I think especially nowadays where we don't need to think so much about the consumption of memory in the sense of at least my usual work situation. But instead, we could also pipe that using a pipe where we would then write first the data set, and then we have this pipe. This is the base R pipe. There's also the percentage arrowhead percentage one from the tidyverse. By now, I'm using this, but just because I don't need another package to load. So totally fine to use the other one as well. It's also totally fine to not use the pipe at all, obviously. And then we would basically use the data, pass it to the filter command where we filter it, and then we pass the result of that filtering step to the select function, and the result is exactly the same as before. So why is this interesting? Well, it's interesting because I don't have to store intermediate results. I don't have to repeat my data argument. That's why these verbs actually take the data as their first input. So basically in an invisible style, that's kind of putting it always in the front of the function. And I can easily remove parts of this pipeline or add parts to that. So here, for example, I could now add another pipe with a range, and then we could arrange the table by the values here. Now you see it's in increasing order. We could also change that by putting a minus before. It's a quick pick to kind of see what's the highest leaf nitrogen content, which has the Pinus sylvestris here. And we could also do some more steps. It wasn't meant to be here. Should be the string R package, which I want to show you quickly here. For example, we could now also pipe it then to the mutate command, and then we could add a column of the genus of each of these species, where we use now the word function from the string R package, another tidyverse package, where we say like, well, only keep the first word of our species. And that's as this as common sense. It's pretty easy to clean up the data here to retrieve the genus data. We'll work with that a bit later. And now, for example, in the next step, I could filter for only the Larix genus or Larix species here, and then return that table. So you can easily basically adjust that and go forward and back and then filter for something else. And that's the idea of it, without running 5 lines of code or 6 lines of code step by step. You could also do that in one step just to show you the flexibility here. Well, this also applies to other frameworks, obviously. We then could also like use the, for example, the str detect function from the stringer package to filter for species that start with Larix. Or which contain Larix in there. So maybe you also shouldn't go in there. Honestly, I wasn't thinking about that because we should maybe use start with and not detect, because detect could mean that also there's a species name where there's Larix somewhere in the middle of the word. So be careful here and think about these things too. Okay. Then finally, for the wrangling part here, we could use a group by command. And the group by command doesn't do anything on its own or nothing dramatically obvious. But it's becoming very interesting if you're using it with some other functions and combinations, for example, summarize. So if we group our data first and then we summarize, it basically creates subsets inside the data frame. So you don't have to create one data set for each species, but basically it uses that information inside one data set. So you see that for each species, we only retrieve one summary value, which is the mean with an A removal turned on. And then we easily can condense the information of, we have, I don't know, 900 observations for one species, but 3 for the other. We could average that. We could also obviously retrieve the number per species and other summary statistics. And now here I'm also arranging that just to see which has the highest leaf nitrogen content on average. Okay. Hope you're still with me. Taking a chance to grab my coffee for a moment and let you think about questions. It seems straightforward. I hope it's not too common for you and it's all basically what you do every day. That would be a shame. And now we're jumping into ggplot or DataVis, where I hope I can teach you a few more things or show you a few more things which you may not know, even though you are using the page before. Asking if the base pipe, so the vertical ruler arrowhead version is the same as the tidyverse one. Not completely, not exactly. I'm not a developer, so if you ask the developers, they would answer no, because they have very different ways on how they act on the data. And from a user perspective, in more than 97% without having this backed up by data, but in most cases, it will behave exactly the same. There are some certain aspect where it works a bit different. There's a good discussion on that on Stack Overflow. I think there was, usually I'm not so much recommending or pointing to Stack Overflow. Nevertheless, there are sometimes good solutions and discussions. And they were kind of also showcasing when it's not working well and so on. I have a look maybe later. There was some person really exploring that with a wide essay and use case examples. Okay, I leave the tab open and we'll send that later. Okay, so for the data viz, I'm using ggplot on a daily basis for years now. So if you have other questions and you know ggplot already and you're always curious how to do this or is it possible to do that, feel free also to ask the questions. I try to keep a few minutes towards the end so that we can also take some questions and comments on that. We will definitely start a bit basic here. As mentioned, it's part of the tidyverse. Actually, it has existed before the tidyverse even was born. So some people would argue, well, it's not part of it, but it's an important part of the workflow and also important part of the collection. And if you look into the description, this is the official description, then it says ggplot is a system for declaratively creating graphics based on the grammar of graphics, which was invented by Wilkins in 2005 or published. The grammar of graphics is a theoretical concept to describe visualizations in terms of language. So we have certain elements that create a graphic instead of talking about specific chart types. So the idea here is that we can describe any visualization, no matter if it existed before or not, in a similar way than those we know for hundreds of years now. And the idea is also to give you full flexibility, obviously, and to create hybrids or mix things with each other and so on, rather than sticking to a grid of choices where you then make your choice and are basically not allowed to leave that chart type. If you continue, it tells description tells that you provide the data, then you say how to map variables to aesthetics, what graphical primitives to use, and it takes care of the details. There's a lot of jargon in here. It's very technical description. What's very important is why I've highlighted here. It's mapping variables to aesthetics because that's a key concept. It's basically the translation from your values into something on your canvas. And well, it takes care of the details. We can discuss that, but maybe we don't want to. It's giving you a good start, and then the rest you're taking care of anyway. So what are the advantages of ggplot2? Similar to the previous things and why we are all here. It's a code-first approach, so we can allow to, or we can create a reproducible and transparent workflow, which is good for in terms of reproducibility from external people, but obviously also using the code again for other projects or for updated data. We have this consistent underlying grammar of graphics we will see in a second. Because of that, we are very flexible and we can, similar to the pipe, add things to our plot or remove them again usually without destroying the current working machine. We have a theme system, so you could use some of the existing themes or even create your own. So that's also what I did for my lab at some parts that point that we created a corporate theme for everyone. And there are hundreds of extension packages which give you additional functionality and additional charts and so on, things you can do. And for me, definitely also very important, the active and helpful community. And that's not just a general statement here, but I really think that the ggplot community especially, but the R community in general, it's special in the sense of how much resources we share with each other and how we talk to each other. So I always like to be part of that and to actively contribute to this. So some basic ggplots, and if you haven't used ggplot before, you may now know what I'm talking about. These gray backgrounds with the white lines, which became a bit of the corporate style of ggplot. We had long discussions about if this is good or not. I was in a friendly way, but maybe sometimes also not in such a friendly way, discussing this with Hadley Wickham himself, why he came up with this design. He's still convinced it's a good one. He's a little bit dated, but anyway, that's might be taste. As you can hear, I'm not a big fan of the defaults, but we will also see how we can adjust that. But these are just some of the charts taken from the general package web page here, which gives you already a good idea about the variability of charts you can create with this library. And then Alison Horst phrased that as a data masterpiece. You cannot only create creative, explorative and basic charts, but obviously also spend a lot of time, maybe too much time for your supervisor or your next proposal on like fine tuning and tweaking your graphics with lots of things. We will just have a short glimpse into that, but I want to give you an idea of what's possible there as well. One motivational example here, I'm not sure if I need to kind of spark motivation here in that group, but usually what I like to show is that the BBC is also using ggplot2, not so much for the interactive graphics, obviously, so there's a lot of JavaScript libraries in there, but they're still using ggplot2 for some of the static graphics and data exploration and more simpler graphs. but you can't even see that this is ggplot. So if I wouldn't tell you, you likely would think, well, any tool, maybe even made by hand or whatever, or lots of graphics designers team. But I even have a BBC cookbook and R package. And I found it very interesting that in there, because it's still journalists without blaming them, but working with journalists and talking to them, it's kind of a very different perspective. And this is changing thanks to the coding approaches, I think, as well, and the digital age. Um, but reproducibility and these things are not usually one of the highest priorities. So I was very, very surprised and happy to see that creating publication-ready graphics in the in-house style made it a more reproducible process, which I found very interesting to read because usually these are things researchers are thinking about a lot, es- especially in kind of how you frame it, maybe. Like it's obviously it makes sense that they want to update the graphics from time to time because they use the same graphics again. But yeah, so it's nothing which is kind of in our bubble. The only thing, the ggplot package became really, really big over the last years. It's over 18 years old now, has a vibrant community, and it's still fun. And some other visualizations, you could create some of mine, some of colleagues and friends. And you see kind of the diversity of things you could do. You can use it for spatial maps. You can even try pixel art or even generative art. So one of these were displayed on the New York Times Square a few years ago. So ggplot even made it there. You could create playful visualizations or very common ones, enrich these things with images and different grid styles. So here we have a spatial facet and so on and so on. So the main components of a ggplot, it's this layered idea. The grammar of graphics is a bit adjusted to fit into a coding context. So the original concept by Wilkinson. So the first thing is the data, which is the data in the data visualization. Then we have the aesthetics I already mentioned. It's kind of how you translate the columns into something on your plot and or where to put it to be precise. And then we have the geometries, is how to represent it basically. It's a layer defining if it should be a line, a point, a polygon, a text label, or whatever. Oops. And then we can add even more of them. There's a statistical layer. Some people also put them together, the geom and stat, as layers. We have the scale functions, which allows us to adjust the aesthetic mapping or the translation of the variables. Then we have the coordinate system, which we usually don't want to really use much because the default is fine for most use cases. We have the facets to create small multiples. In the end, we have themes to create or to modify everything which is not data. So everything which is the beauty. Okay, mentioned that already. So we have to load the package. To clarify here, we often talk about the ggplot package, even though strictly speaking, it's the ggplot2 package. There's no one really using the ggplot original package, so we just say ggplot because there's no ggplot1, no ggplot3, so we often get rid of the two. But to be precise, there's a ggplot function and a ggplot2 package. And the ggplot function is what we need to initialize a plot, and usually we use it to pass our data. So the first line is ggplot, and then the argument data equals. And then here we pass the TriDB dataset we have imported. And then with the plus sign, we can add a new layer and we can add the aesthetics. Here we say, okay, what to put on the X and the Y. And in the final, we kind of put a geom and then we get, oops, not a nice box plot. This is on purpose here now. It's due to the long label, so you can directly see that ggplot is not taking that much care of the details as it claims. The plot has disappeared because there are kind of these long labels. So we're going to work with this in a second, but I wanted to focus on the structure anyway. I'm surprised that there's no question yet about the aesthetic being placed outside. So maybe there are not so many ggplot users or very experienced ggplot users, because that's some people claim that this is how you should always do it, but that's rarely what you see if you're looking at our code. What's usually happening is that people, put the aesthetic inside the ggplot call. So first of all, I'm a bit too fast here. So that's the long version, basically, where we have the aesthetic function on one line, and we could also spread it out like this, for example. This is what you're going to see on my slides mostly because I kind of have a long format here with my column view. But what most people do is usually, and I also outside of this workshop, is that I put the aesthetic inside the ggplot function. So both is possible. Then we need to kind of put it as the second argument, which is the so-called mapping. And if you recall, we map variable, so we're mapping variables to aesthetics. That's the logic of it. And then we could also use implicit matching. This is not specific to ggplot, right? It's art or maybe even programming language wide concept where you kind of like can get rid of the argument names if you follow the exact order. So if you follow that the first argument or the first input is the data, and the second is the mapping. And then even inside, not recommended, but even inside the aesthetics, you could say like the first is always X and the second is always Y. I'm going to use a mixture of this. But first of all, let's take care of our graphic that we really see a plot here. So for now, I'm just truncating my names. You could obviously also wrap them, but some of the trait names are very long, and as we are still in the explorative phase, I want to keep things going. I don't want to mess along with how things look like in the final version. So I use this trunc function from the stringer package to truncate my trait names. And you see it's adding a dot, dot, dot if there are too many symbols in there or too many letters in there. And this is also something to show you that you can change the data on the fly. You don't have to overwrite your original data set, which is again a bad thing to do in the context of the FAIR principles and the reproducibility and the later usage of the data. So we don't like to make a copy or overwrite these things, but to handle it on the fly. Now we see that we have the seed number per reproduction, even with a typo, as you see here, has very long numbers. And then we have lots of them where we can't see the distribution at all because it's all somewhere close to zero in that case. We could now, thanks to the idea of the grammar of graphics, we could simply just change the geometric layer here to create another plot. So that's basically the idea. I don't have to prepare the data for a specific chart, but I can have a basic setup and then flip through different ways how to represent the data. A jitter, geom jitter creates a jitter strip. So it's the raw data. And then it's here in a horizontal, but you could also have it vertically by just flipping X and Y. And then it's basically adding a bit of noise, so the points are not all plotted on top of each other. Nevertheless, we see the same pattern as with the box plot, obviously. Makes sense because the box plot is taking that information to generate the summary statistics. We could also then adjust the geoms. For any geoms, they have their own arguments. So for jitter, for example, we can adjust the height. So we see going back and forth that here they are almost touching the groups, the different traits. Now we have a bit of space in between, and then we add some transparency. So a bit too much maybe on the gray background, but you see there's lots of overplotting. So this idea to kind of see how many points there are, we can see that for the leaf area, for example, and the dispersal unit length, it's definitely less than for these, but not much more. So let's move on. We could, for now, for just getting an idea, we could logarithmize the axes. There's a quick way to do that in ggplot. We could, or actually multiple ways. We could add a scale. So here we want to address the x-axis, which we want to turn into logarithmic. So we can use the scale underscore x underscore log 10 function to do that quickly. You could also wrap the x input here, the aesthetic, into a logarithmic function. Or you could also go the way that you go the chord function, and then there you could also transform it. And now we see a bit more of the data. Pay attention that we are now looking at logarithmic, so we don't want to make conclusions of that, but we see a bit of the variation inside the data. Another tiny trick, which sometimes makes sense, is if you're having many zeros, it makes sense to add 1 to your data, just to avoid these non-numeric calculations when using the logarithmic here. Nothing you should publish like that, but a quick trick if you investigate. Another important explorative visualization is the histogram. So that's quite easy to do. I mean, it's even easier in base R, obviously, but with the benefit that we get all the flexibility of ggplot here. So we pass the data set again. In the second line, we only need one variable or one column, because the other column or the other axis is calculated from the data, right? So we put the value on the x-axis, and then the count is estimated from that. So it's counting the number of observations per bin, so per step of our x-axis. And then we simply use GM histogram and retrieve a histogram. We could now modify it. So you likely know that the histogram binning influences how we perceive the data. So we could, for example, set the number of bins. So now we have exactly 50 bars here. Not saying it's better or worse than the other. We could also adjust the bin width. So this is basically the value step of each of the bars. So it contains 0.2 of the data, basically, unit steps. So we have basically 10 bars between 0 and 2, if I'm correct. We could now also play around with the aesthetic. Nothing you should create, just an explanatory visual here, nothing definitely for publication. But we could now pass the column to another aesthetic. Here it's the fill aesthetic. We have a new aesthetic inside our geom. We could also add it to the second line here. This doesn't really matter in that case. Not going to go deeply into that, how aesthetics work, but basically we say like, well, in our histogram, please use the fill color to represent the species. And we see that we have way too many species to really make this meaningful. And on top of that, we have a stacked histogram, which is hard to interpret. But at least we get an idea about the species which are in there. And yeah, the colors are not helpful. We could also make this now, if we want to really go into explorative again, we could make this an expression as well. So we could also map something which returns true and false to our aesthetic. So here we say, please color those data values which are the Pinus sylvestris in a different color than all the others. And you see with the legend here that the red one is false and this one is true. So we see Pinus sylvestris has quite a large share here, and the peak might be a bit moving to the right compared to the overall data. We could also use something which we have used before to maybe just plot the genus, which makes this a bit better and maybe closer to something publish-worthy. So here I'm now again on the fly using a string-r function, the word function, to retrieve the genus from each of our species. And now we end up at least with a, if I'm correct, 9-10 color graphic, which is not perfect, but works very much better than the other one. Ah, cool. Thanks for the poll. Go and have a quick look if there's. Oh no, might take too long. Okay. And if you want to overwrite the colors, just giving you an idea here, there are many ways to do that. And if we're going into data with theory now, this is definitely a case where there's slightly too many colors anyway. But we could use, for example, the rcato color package. I didn't like all the ones I tried from the default ones, where we have dedicated functions to use the car2db colors. And here I'm using Prism, for example. I can also overwrite the name of my legend directly here inside these scale functions. And yeah, it's not a great graphic, but at least something which we could work with. Maybe even better than a stacked histogram could be a facet. So we could create small multiples with ggplot. Here we are adding the facet wrap, which means we usually pass only one variable to kind of create not a grid, but a column row layout of our data, of our subsets. So the idea is that we, with the shortcut version of the circumflex, pass a column name or even a modified one. So here I'm again using genus on the fly. And then it basically splits the visualization into all the groups that are available. In that case, all the genus. And here we get all these 10 genera, and you see that they keep the axis by default. The axis range is consistent. That's why some of them look very empty. This is because some of the genera are heavily over or dominating this data set. So we see like the Pinus and the Cracus, Phagos, well, maybe the ones you would expect here. Okay, yeah, so facets are a great way for explorative and explanatory reasons. So I want to motivate you to use these. Um, we are moving on to maybe something we often create as scientists, maybe should think about if box plot representation is still a good thing to do. I became a bit known as a bad box plot hater, which is not true. It's kind of like a work of art, putting all these summary statistics in there, but they can trick us. And nowadays, we're also often interested in the distribution of the data, not only the center population of there's lots to discuss about that. Would be great to kind of be in the same area and then have this for lunch or whatever. So focusing on ggplot2, but happy to elaborate on that a bit. Or point you to some articles. So here now we're creating a box and whiskers plot where we again need two variables. So I always have these flip versions to make room for the labels. Um, so we have the species name on Y and then the values on the x-axis. And now we're working with this, what we can do here for the next few minutes. We could also turn that into an error bar, obviously. There's the stat summary, and now we, for the first time, see a stat layer, and the GM layer and the stat layer are basically using the same thing behind the scenes, but they're a bit of a different perspective. So the GM is basically, well, I have my data and I want to show it as a line graph, point graph, whatever. That's the most intuitive thing for most people. And then there's some people in the world which think the other way around is like, well, I want to show my raw data and maybe I show them as points. So most people think of like, well, points and it's raw data, but some people coming from the other side. And here's the idea that I want to show summarized data, and then you can basically pass the GM how you want to show the summarized data. So it's both leading to the same results, but a bit of a different perspective. And the stat summary by default, we can't see that, so we would need to go into the help to see what's actually shown here. And that's obviously also a criticism of these error bars or point ranges or however you want to call them, that it's often unclear what's actually shown. And then it's the next thing is frequentist or Bayesian, right? And different fields have different conventions. Nevertheless, it's something we use for communication of our research findings. And the stat summary actually shows the mean plus minus the standard error. That's at least from what I know, not what we usually report. So let's work towards something more meaningful in our context. So the stat summary has some default values, but you could also pass your own. So if you want to build a mean plus minus standard deviation version, you have to code it yourself. I didn't bring the other one. I always find it complicated, but there's also a semi default one you could use. I usually code my own little functions here, which is maybe sounds scary, but actually should be simple enough to do. So stat summary usually returns three values. One is the minimum value, one is the y, so here in our case, the x min, x, and x max, or if we're going vertically, y min, y, and y max value. And either we can create them in one step by using fun.data, or we are using all of them or creating all of them step by step. So the first thing is the x or y value. It's the mean value. So we can use a preset function here to basically create the mean for the dot. And then for the minimum and maximum, we're creating a short function where we say, well, from the TriDB nitro data, split the data into all the different species, pass all the values which you find per species into this function. So here the X is basically taking all the STD values from our TriDB nitro data per species name. And then it calculates the mean, should remove all the NAs, so we get a number from it. And then it should subtract or add the standard deviation from the same data set. Okay? I hope that makes sense. And now if I flip forward back, We get a bit of a different picture, obviously, because then error standard deviation differ from each other without going now into the details. And then finally, and this might be a good wrap up for the session to leave a bit of space for questions. Let's see. We're going to polish the data visualization. There are a few more slides on that. That's definitely something I'm maybe enjoying a bit too much. I also want to give you a bit of good practices and tricks and things how you could do that. It's becoming a long code, and I don't expect everyone to write always kind of like very long codes for like a tiny graphic, but I think it's worth it if it's really one that ends up in the main part of your paper. I think it's definitely reasonable to spend quite some amount of time on that. I'm getting a bit sad sometimes if people are like, well, how much time did you spend on your figure? Is like 2.5 hours. I mean, there's all the pre-work, but the figure itself, maybe it's like a Friday afternoon product, which is, if you put it in context of how much time you spend on collecting the data, or maybe thinking about the project, writing a proposal, collecting the data, analyzing the data, I think we must give it a bit more room from time to time to spend time on the communication of these. So here, what I'm going to do is, maybe some of the details are too much, but showing you the usual steps. I address here in the first step the x-axis, where I'm going to change the expansion. So if you look, especially for the histogram, you have seen that very nicely. And we can quickly go back. That ggplot always adds a padding around the data. And some people hate it, especially for bar chart. It looks a bit weird because they are basically flying in the air, so they're not having a proper baseline here. That's the so-called expansion, and we can remove that, for example, by addressing the axes. So here the scale x continuous, and here it's the more complex thing. There's also shortcuts for that, but here I say like, okay, for the expansion, I have to pass another function where I say like, okay, on the minimum add nothing, but on the upper end add a bit. So we can like get some space for the label here, but here we have a proper zero line. If it would be bars, it would be more visible. I reverse my order here. So I have kind of like alphabetical order here. If we go back, it should be the other way around, because as 0 is here and we're going up, it's the logical way of when we plot something, but not what we want to read. So if you want to keep it alphabetical, I can change that. And there's a quick trick to do that. We can just pass reverse to the limits argument, and then we flip these categories. In the next steps, oops, wrong highlighting here. I'm adding my labels. So here on the X, I kind of write the exact description of the trait, and I remove the title on the Y because it's species that should be obvious, that should maybe like be written in the title or the caption. So I'm removing that. There's a slight difference for the R users in the room. If you pass an empty string or if you pass null really means removing that. If you would put empty strings in here, I didn't bring an example, but you would then get a white line on the left of your text because there's still the placeholder for the axis title. Then I'm using one of the complete themes ggplot comes with, so not the gray one. I'm using the minimal in that case because I think it works well with these type of plots here, where you also can override directly the base family, which is the typeface used for all the text labels. The font needs to be installed on your system or on your server, whatever you're using. And I can also adjust the base size. So the default base size is 11, which means it bumps up or bumps down all the relative or the base size to where the size of the text labels and the line width and so are based on. And then in the last step, I modify a few details of that complete theme, where that's one of my major pain points for why I'm basically ranting about the original default theme. I'm always getting rid of the minor grid lines. So there's these thinner lines in between our axis steps usually. If I go back, that example here, these thinner lines in between where there's no label. So some people would argue should not, if there's no label, should not draw a line. I get the idea of intermediate steps, but what I especially don't like is that there are too many grid lines for my taste, and then especially the different width of these lines adding more noise to these kind of graphics. Okay. I'm also removing my major grid here. Some people would maybe argue that it's helpful to match the labels to the error bars, so it might be fine. And then I'm also making my text on the axis italic because it's species names, right? And oops. And I make it left aligned instead of right aligned because in that case, I think it looks way better. Um, One thing I missed is for the scale X, because I want to mention that explicitly. I don't think you need this one. Get rid of it. I got rid of it at some point, it popped in again. But what I want to focus on is the labeling here, the labels. So from a ggplot perspective, but also from a data viz perspective. So here we can pass a function or also a vector of labels, or a function that returns a vector of labels. And the helpful package here is the scales package, which is a companion package to ggplot2. And here, for example, we could use the number underscore format function where we can add a suffix to our data. You could also create your own little function and paste it together, but that's usually more convenient and less tedious to write. And I'm putting the unit in my axis, and that's often something which gets a lot of discussion. If you should do this or that, should I put it in brackets or in parentheses? That's usually the first discussion, like what's the correct way to do that? People from physics do it differently than people from biology, for example. The usual data viz recommendation, if you look into the community and into books and so on, is to put the unit not in parentheses or brackets, but put it on the axis if it's not very long. So it's not about the axis title, but it's about what it is. It's kind of like counterintuitive a bit, or maybe the opposite to some of the rules where we say, well, we should avoid repetition and too much stuff, which is basically cluttering our plot. But here the idea is really that I don't have to read the title to get what it is. The same, or maybe even more important, if it's about 10,000s or millions, where people then put the tiny million symbol somewhere in the title, but it's easy to miss. And this is actually something which can happen, right? You're looking at the numbers like, well, just 3 people died, and then somewhere they're standing like, oh, numbers are represented in millions, actually, right? So especially in that case, it's often recommended to put these symbols also into the axis labels, not only the axis title, or even worse, somewhere else as a tiny footnote. Okay. Um, just quickly, how we could reorder that. Maybe you don't want to have an alphabetical, but order it on the actual outcome of the data. By the way, it's not such a meaningful graphic in the context of the data set, right? This is what we leave for the practical session. But here I could use the forecats package, another tidyverse package, which has these functions to work with factors. And here we can say we want to reorder our species based on our values with the mean function. And then you see it's ordering them from, I think because we still, now I removed the reverse, so it's ordering from high to low, and we get a nice ordering here. We could also say like we want to have the max value or some other values. Yeah. And to kind of add or close the discussion on should we rather aggregate our information and summarize it or show the raw data, I think often we can combine both. It depends a bit on the data set. For this one here, I think it works very well that we can put a jitter strip with a bit of lighter colors and transparency in the back so that we can still see the raw data. It's definitely depending on the data and if it makes sense. I think here it makes a lot of sense because we have the different sample sizes and the different types of distributions. So it might be a valid additional information. So we put it behind the stat summary because it's kind of like in order. So we first plot the jitter and then on top we plot the error bars. Or we could also here jump to the genus perspective, right? If you at some point, well, it's too much information, too much going on, we could move there. So just showing you that you could also on the fly, we've seen that before, create a genus column, but then we can even pipe that into ggplot so you don't have to store a data set. If that's not very heavy to calculate, I think that's what you'll see often. Or you could then, if you still like your box plot, obviously use a box plot and put it in an error bar. Then again, now we're switching that. We put the box plot behind the jitter because there is this filled box here. So we first draw the box and then on top the jitter. Okay, that's I'm going to skip. Already assumed that I'm not going to have time to kind of show both examples, but nevertheless, I was working on both anyway, so I thought I'd bring both. So if you're interested on creating another chart with maybe more meaningful one with the GBIF data, you feel free to look into this. As mentioned, oops, no. Um, you will have some time to create your own graphics. So it's about some bar charts of the most common species inside. Just gonna give you a short glimpse what I'm covering here, or note one thing, which is the GG text package. So if you're a ggplot user but you haven't used GG text before, then first of all, I'm pretty jealous because it will be a great first moment to use it. And second, it's a very helpful, especially for biologists, a very helpful package because we can italicize specific words only. Not we don't have to kind of italicize or bolden the full title. And in combination with HTML, a bit of HTML code, it also allows you to make a bit more of rendering of these words. So we could even go for colored words in titles or labels. I know this is not usually what you do for journal figures, but it's what we see currently as an, yeah, it's not a new hype, but again, a pattern you see that people are getting rid of legends and colored titles or colored text to help people connecting the data with the textual information. And with this, saving the graphic just shortly, but this is important. Obviously, you need to kind of get it out of RStudio or whatever IDE you're using, and then send it to your supervisor, your colleagues, and finally to the reviewers. There's a dedicated GG save function. You could also use the device way, where we kind of specify the plot. By default, it always saves the last plot. We can specify the width and height, which is in inches. For publication, it's important to kind of also adjust the DPI, the quality of your image. It's the density of pixels here, where we kind of like, usually the journals recommend or request at least 600. So make sure to set that because the default, I think it's 100 or maybe even less, I don't know, but very, very low resolution. Um, if you kind of going with raster, obviously, you could also, if you have specific measurements, you could also switch to centimeters or whatever unit you prefer. And then finally, if you want to have not a raster graphic, but a vector graphic, so lossless quality, you can also save it as a PDF. Here, I want to note that the community in general is using the device equals Cairo PDF for that because it gives you the best quality. This is some technical how you render a plot to PDF and whatever. But if you're using symbols, if you're using custom fonts, whatever, this device gives you the best results. So I mean, I always do that, or like think of me, or at least of the slide, once you run into issues when saving the PDF and look it up. What was the solution to that? And finally, if you nevertheless, and I'm doing this as well, want to do some adjustments by hand, some modifications, you can also export it as an SVG file, for example, as an EPS file. So there are also other formats available where you then can, yeah, work on with that graphic further on in Adobe, Illustrator, Inkscape, whatever you prefer. Okay. With this, I wrap up. I'm not going to read out the components again. We have not seen, we have seen all of them to some extent, but very shortly, obviously, there's much more functionality. I want to, because there's so much more, I want to end this with some overview and again, not going through, but as a resource for you, a list of exciting extension packages. So if you feel like you want to explore a bit more, there I structured it a bit. So these are layers. So basically not map, maps as well, but chart types you can't create easily with ggplot alone. So here we have uncertainty visualizations for distribution. We have bump charts, B-swarm charts, dumbbell charts, all kinds of things you could think of, maybe even never heard of, and you still first have to investigate what's the chart type in the first place. Here's a continued list, some of them giving you more shapes or some other utilities. I have a dedicated utility section that's all about creating multi-panel plots or making text rendering and yeah, shaders and patterns and all this stuff. So there's lots of additional things you could do. If you're not happy with the themes that are out there, but you don't want to create your own, these are some of the theme packages you could use. Especially this one is pretty neat, the HRBR themes. Colors, there are also a lot. Be careful here because not all the packages are usually by default colorblind safe and linearly developed. So there are lots of bad colors out there. I'd love to talk about that as well. But we're limited here. So, and finally, interactive charts, nothing we unfortunately can use currently for our publications, but maybe as an additional thing, or maybe for your interactive poster or whatever use case you have, a list of interactive charts. And most of them are using JavaScript in the back, but the first two are actually working on ggplot at least. And I really love to work with gggraph currently, which is a pretty recent addition to the universe, but works very well for hoovering effects and all kind of these. And with this, just in time, I'm closing this. I'm happy to stay a few minutes longer to take any questions or whatever you have for me. And I hope this was something valid and insightful. And I wish you a lot of fun during the rest of the course, but especially during the practical session this afternoon.